number 6 right now.
Okay, no problem.
All right. Math efficacy. So what does this question need us to do?
Get the results. We have to open this up in our software?
Yeah, I'm opening it up right now.
Me too.
Okay. So compute the residuals using software. Explanatory score confidence as explanatory and score data.
Actually, the only one I remember is 5.
We said the residuals look normally distributed because that's why you do the QQ plot.
Okay.
It's in that section.
All right.
White hat. Okay.
Use the software. Okay. Suppression.
Clint, are you doing this in Excel?
Yep.
I'm actually using the SPSS.
Yeah,
I am too.
don't understand Excel.
This, I think though, watching Clint do it, I think it's easier. This far into it, I'm not changing what I know.
I know. After he tells us how to do it, I'm like, that's so much easier than having to put all this into SPSS.
What's that, Big Nugget? Work. Yeah. I call people. They
Why am
usually don't
I
have.
not finding my normality plot here?
What is it that you're looking for?
The normality plot. It's under plots and then down in the bottom. Okay.
The SPSS is taking forever to load.
Oh, that's not good.
It always does this stuff I like. Weren't Clint's graphs just beautiful?
They were awesome. I loved the colors.
Yeah. It was fun. I learned actually how to do all that stuff on my mission. It's pretty funny.
Oh wow.
My mission present one of the terms in businessman.
You know, though, what a good secondary thing to learn.
Oh, it's come in handy.
Yeah. That makes me understand why you understand what we're doing better than we do.
What did you guys get from before while we're waiting for everything?
I wrote down B on my paper. Yeah, B.
Okay.
Okay. Which the residuals are between 40 and negative 40 and 25. All are negative or a linear. I think it's going to be the linear one.
I think it is too. Linear.
How did you get the graph?
So I went to Analyze and did a regression, linear, and then went to statistics. Let's see if that's right. Nope. I went to save and checked the box for residuals and standardized on the right-hand side.
So the very first thing you did, you went to analyze or graphs?
Analyze.
And then to regression?
Yep.
Linear?
Yep.
And what did you put as the dependent?
Well, I said that the dependent, because in the thing it said the confidence is going to be the explanatory and the score was going to be the response. So I said that the confidence is the dependent. Nope, I did that backwards.
Confidence rating mean is the independent?
Yep.
And the score is the dependent.
Yep.
And then the statistics, you had confidence intervals also on there?
Yes.
And then you saved it unstandardized on both sides?
Yep.
And then plots?
I didn't do a QQ plot from there because I'm still a little shaky.
Okay.
I didn't run that much, and then I go back to the data and run another QQ plot on just the difference in that unstandardized width column it gives.
Okay, so then you go to the simple scatter, define. Correct?
Yeah. Yep. Simple scatter or legacy. Then I go to legacy dialog. Scatter dot. Simple scatter. Define. And then mine is going to be.
So you put the unstandardized residual up at the y-axis?
Yes.
And then did you use the score and the x?
The score, confidence is going to be X, right? Because, nope, you're right. Score is X. Because it's the. No. Yes. Explanatory response. I think explanatory means that it's your constant one. And the response is what it does to it. So I think it's confidence. What do you, anybody else chime in on that? Because I'm really not sure.
I think you're right, because that's what the question was asking.
Okay.
So this is a question in Excel. How do you get data files in Excel? Do you just download them the same way? You just go and click on the SPSS version, you just click on the Excel one?
Yeah, that'll work. I actually downloaded in the semester. I downloaded a huge zip drive that had a bunch of them, and so I actually just have it all on the computer already. You can do the same thing at the website. I mean, the textbook.
Okay, can somebody screen share? I want to see somebody else's confidence rating kind of thing.
The actual.
SPSS isn't working, so I'm trying to do it through Excel.
You're wanting the actual scatter plot?
I want to see your scatter plot and see if it looks like mine.
Let me see if I can get it. Let's see. Can you see it?
Yep. Oh, let me click on you. Hold on so it doesn't go away.
Is that what you got?
I'm going to go look at my score. Standardized residual.
So Rusty basically said that the score was dependent.
That the what?
The score was the
No,
dependent term.
no, I think we decided that the confidence,
Confidence rating.
which, Rusty, if that, so which one do we think is our X? Is it confidence or score?
Score.
It's score.
No. Confidence is X and score is
Okay,
Y.
so if confidence is X, Rusty, I propose that maybe your graph isn't right.
Okay.
Because you have score on your Y. So let me share mine and let's see if we like this one.
I'm going to start all over on this one because something just isn't. I've got too much stuff.
So Clint, while we're working on this, how is it that you came to jump ship and join our group?
I kind of have
have
a pretty
busy
schedule.
schedule. I go to school in the morning, and I homework in the afternoon, and then in the afternoon I go to work.
So I
I start around 7, don't really get done till like 8.
Gotcha.
So
yeah,
yeah, I actually just up eating a little bit ago, and so I have a crazy schedule, and not a lot of people can accommodate that. And so, and then I heard about a group that met at like 9 o'clock at night all once a week. I was like, hey, that'd be perfect.
In the middle of the night. These silly people.
So it fails. Okay, I'm trying to get to like my SPS isn't working.
Is this graph look right to anybody?
Yeah. What does yours look like on Excel, Clint?
It doesn't give me a residual graph.
graph. I think you
I
have to
have to
make
make
one,
one.
which I'm not exactly sure.
I'm looking. I don't know either. I'm looking at the instructions for Excel. My SPSS isn't working, and it's not
You know what,
giving
I
me
could-
that Tanny has.
Okay.
I can actually make it. Okay.
So I think we kind of need to pick an answer and keep going. Because, okay, we know that it's not the first one because we can see the data, right? And it's not between -40 and 25,
Right.
right?
And I don't think they're all negative. I think it's
I was looking at it, and I've got the residuals in front of me, and they're not all negative. Now let me see if I can, see if there's a -40.
Can
I have a negative
can you show me
38.
your chart, Tanny, one more time?
Yeah,
The
just
one that
give
you
me
got?
just a second. I will gladly do that. You know what? It might be the first one. Because I do have a -38, and I do see a positive. There's a 15, 18, 19. So it could be the first one. Okay, Rusty, let me screen share and I'll show you mine. I have a touch screen, and every time I go over to this other software, it won't let me use my touch screen, so I end up touching the screen for no reason. Anyway, that's what I have, Rusty.
That still doesn't look like mine. I'm not sure how I'm messing up.
And it could be me.
I'm having the hardest time. I'm gonna have to reinstall my. Uninstall my VMware and reinstall it, I think.
Okay, so
There you go.
so all residuals are between -40 and 25. I could go for that one. I don't think they are for a linear pattern. Looking at mine, what do you get when you graph it out?
No, I finally made one. I had to make mine.
Show
Show you real quick. That button.
Okay.
Oh yeah, there you go.
Okay.
Okay. So this is what mine looks like.
Yep, it's not linear.
That's it. No.
Okay, so we're going to go with option A.
Yes. All right. Let's go into something.
Okay, based on the QQ plot for these residuals, what can you say about these residuals? They're clearly not normal. They look right skewed. I'm going to say they're fairly normal.
If they
Because
weren't normal, there would be a pattern, right?
I could be wrong, but I thought in the videos they shouldn't have a pattern. They shouldn't be a megaphone or anything. They should just kind of be randomly all over the place.
Yeah, that's what I understood too.
Okay. So 7 is C. 8.
7 is C.
C is in count.
Okay, that's for 7.
Yeah. 8.
Okay.
Use the software to create a scatter plot.
Given the scatter plot is the sort plot and the QQ plot, which are the 5 assumptions about linear regressions are satisfied by this data. There are 5 requirements for a linear model.
So we know that there's definitely a linear relationship between the two of them because of the original scatter plot of the data. Because it's not like random, it's linear in a degree.
And we said
So I think it is 1, 2, and 3.
That's a
I know what that means. That is the one we just did. So you do 2 Q-to-Q plots. And one of them you do on the variances, which is that one that you don't want it to be a megaphone or have anything. And the other one you take, you take it and you put it, how did I do that before? Let me see. Graph. Oh, I know. You did just a QQ plot of that by going to Analyze, Descriptive Statistics, down to QQ plots, and then you did it for the residual as your only variable, and you said OK, and then that should have some type of line to show, and I can show you mine here. Let me screenshot real quick. Sorry, I have to kind of pass back and forth between that other computer login thing and here. Okay. Can you see mine? That QQ plot there? And I'd say that's pretty doggone normal.
yeah.
Yep.
So that's a QQ plot and standardized residual, which I think is what it's asking us.
I am just, nothing's working for me tonight.
The variance of the error term is, so, okay, so the residuals are normally distributed. That's that QQ plot that I just showed. And the other one that's kind of like scattered all over the place, that's the variance is constant for the error term, that it can't be a megaphone.
Gotcha. No megaphone.
Okay. Next.
So the B1.
The next one is, what is B1? The estimate for the slope.
I have 12.725.
And your answer is going to be a little different than ours. Let's see what I came up with. Now slope is down, it's that second line, isn't it?
Yeah.
It's our t value, right?
The slope?
No.
Yeah. It's the t
Is
value.
it t or is it b? Nope, it's t. 12.424.
What did you get?
12.424.
You're saying that's the what?
Is the slope your t value, or is it an unstandardized coefficient? I don't remember.
I think that the unstandardized coefficient.
Okay, so that's going to be 12.695.
Okay.
Is
Yeah, because I have my T statistic is 12.476, which is closer to what you had previously.
And that's 1.296, Tammy.
No, I have, okay, let me look at it again.
The slope is given in the second row of coefficients table, which is labeled, then whatever it is. This one was head length.
Is it the B?
Share your screen with me and I can tell you. Or I'll share my screen and I'll show you what I found. That's what it will do.
Okay.
Can you see that?
I'm clicking over here.
It says right here. Oh, where did it go? Here we go. The slope. Where was that? I just found exactly where it was at, and as soon as I moved over, it jumped sideways. Here we go, it's right here. Slope.
Test statistic, is that what you're trying to find?
Trying to find the slope, like where the slope is. Here it is right here. I think. Yeah, it's right here. So that there is a linear relationship with the two variables, the slope, the difference from 0. And
Yes,
so
but which number?
No. This is in the second table. Here we go. The information related to the slope is given in the second row of the coefficients table, which is labeled head length. So, head length, clicking across the second row, we'll find the value of t, which is given. T equals 35.5. I don't know if that's helping or just confusing us more.
So T is going to be different. I know T is not the sum. So I agree with, I understand what they're saying.
Okay.
That we're going to use the B in the coefficients part.
Okay. So what did you get for number 9? Because didn't Clinton say he got something different? But that was in Excel, right?
Yeah.
So I got 12.695. What did you get, Rusty?
If it's the unstandardized coefficient, from what I remember, I'm getting 0.042, but nothing is coming up right at all. And I'm trying to find where is
It's going to be.
I'm not. Tanny, can you walk me through the actual where you're coming up with?
Yep.
The answers?
Okay, you bet. So from the beginning, okay?
Yep.
Opening the data file.
Or the math sufficiency.
Yep.
On the SPSS.
Okay, so we're going to go to Analyze, Regression, Linear, we're going to choose our dependent to be confidence. Oh, I'm sorry, you're right. Yes, score. And the independent is confidence. Then we're going to go over to the statistics button. And I'm going to click that I want a confidence interval. And then I'm going to tell it to continue. Stop me if you need something.
And you're still in the linear.
Yep.
So statistics with the confidence.
Yep.
Interval. Click save.
Yep. No, then we're going to hit save, and we're going to hit unstandardized for both boxes. And continue. And then I'm going to go to OK. And then it comes up with the first table is labeled variables removed, then model summary, then ANOVA, and then you go to coefficients.
And, okay, now I have 12.695.
Yep.
And the one above it is 18.690, which
That's right.
Thank
Yep.
you. My gosh.
Okay, what is the confidence interval? Well, that fortunately is going to be right there in that software. 10.674 to 14.715. Do we like that answer? 10 point.
Wait, which one was it?
Oh,
Yeah.
yeah, mine is off just a little bit. But
Yeah,
I'm
mine
gonna.
has mine actually has it perfectly.
Okay. But we'll go for the first one.
So funny how Excel does that. Like sometimes Excel has it right, and then sometimes SPSS has it right.
Based on the evidence and using. Okay, for our hypothesis test.
So V1.
Going back over, I have a p-score of 0 almost. So
Oh, I have a p-score of less than 0. It's like 0.00009 something.
Yeah. So I would say B.
Wait, if it's
Reject the null.
smaller, we reject null hypothesis, don't you? B. Oh, B. I thought you said D for a second. I was like, what?
No, B is in boy.
Okay. I was like, I could have sworn maybe I'm getting this wrong.
No,
Okay, yeah.
you're right on. Okay, for a hypothesis test, B1, if you reject the null, what does it mean? It means
There was sufficient.
so is it C?
Yes.
Yeah.
It's not.
Boy, I feel like I know so much about crocodiles after the last 3 weeks in this class, though.
Did any of you watch that video that from the text?
No.
I watched the videos.
No, the video that is in the text. It's a 15-minute video. Well, actually, it's an hour, but we were only supposed to watch the last.
No, I haven't watched it yet.
Some mega crocodile from prehistoric time. That thing was pretty huge.
Like the Mesosaurus or whatever it's called.
Yep.
I only remember that because of Jurassic Park.
Okay, number 14.
Which variable is dependent?
Oh, 13 is body, right?
Yeah.
Body.
Since the 99% confidence interval for these data is, what can you say about B1? No. It's B, right?
So it's B, the 99% chance?
That's
I don't
my
know.
guess.
I don't ever like when it says 99% chance because the chance is usually not the right choice.
That's what I thought, but I mean,
I
it's
think
not.
it's the first. I'm sure it's the first one. And I get to submit first.
Oh, yeah, that's right.
Because if it's...
It is because it talks about it in the video.
Yeah.
But if it doesn't, that's right. Okay.
It said in the video if it has a 0 in it, then there's a chance that it's not a linear line, that it's 0. And so this doesn't have a 0.
Oh, it goes from 10 to 14, right?
I usually go
Yeah,
from
well, that's what gives different numbers, but yeah. Okay, should we review from the beginning? Yep.
Alright, 1 true, 2 true, 3, C is in cat, 4,
Oh, hold on.
2 true, 3 is the third choice.
Yep.
4 is what?
the second one, B is in boy, the 5th one is the very last one, the 6th one is A as in apple, the 7th one is C as in cat, the 8th one, the first 3 are check marked and the last 2 are not. Number 9.
Now, I was thinking I heard something else for 6. 6 was A.
I think that's what we finally decided on, am I right?
That's what I have marked.
Okay, and 7 is the B.
C is in cat.
D is in cat. That's 7.
Yeah.
Yep.
Okay, and then the first 3 choices for 8.
Yep. Number 9 is 12.695. Number 10 is A as in apple. 11 is B as in boy. 12 is C as in cat. 13 is B as in boy. And 14 is A as in apple.
Okay, I'm hitting the submit button.
Kenny,
Yes?
it's my turn. You told me last week I was the one for this one.
Okay, have at it if you want.
Save for, or no. Hit the wrong one. Submit. 100%.
All right, we rock.
Yay! Yeah. Ugh, I can't believe there was 2 this week, and it wasn't just a small one.
Okay.
Do we have
So
some next week?
I don't know. I haven't looked ahead that far.
I don't think we do.
I think this is it.
I think so too. Okay, I'll be right back in 2 minutes.
We just have to get that group project, you know.
Oh, no, wait, just kidding.
Maybe some emails on that or stuff, but...
You have to meet next week.
Oh, we do?
Yeah. In the course conclusion folder, there's the Unit 4 exam, and there's individual preparation and a group meeting.
No way.
Yeah.
2 exams in a row.
Well, but we're doing the Unit 4. What exam are we getting ready for then? As part of this number 24.
Yeah, this is really confusing. Maybe she's just making us do 2 days in a row?
Because
This is
the
a review
individual prep, yeah, the individual prep for this one led us to an exam prep page.
That's fine. There's no, in week 12, there's the group meeting exam, but there's no actual exam to take.
Huh.
But when you go into the individual preparations, it says please review for exam number 4. And when you open it up,
Yeah, there's a quiz there. So when we open the group meeting, what does it do?
Mine says it's not available yet.
For next, well, for the 25th, yeah, mine
Yeah.
says the same.
Oh, mine works.
The 25th,
24th.
lesson 20. Oh yeah, we're talking about lesson 25.
yeah, so this is just the review for that quiz next week, I guess.
Oh,
All right, let's get at it because it's a big one.
yeah, it is.
Yeah, there's only 43 questions.
And
Yay.
you know, here's the other thought is depending how late you guys want to stay to do this, we can also, it's not due until Thursday. So if it's just way too much, we can say, okay, we're going to come back and finish it Thursday too, you know. But
Right, I am
Okay.
so loaded this week, but we can try to get what we can try to get done.
number 1,
Yay.
Day 24, group meeting start.
oh, are you actually doing it in there?
Oh,
Is there
yeah,
a
I am.
save later button on those?
Yep.
Okay.
We could do that, or we could go ahead and do just the preparation for it, which is we're told
No,
that it's the question.
I'm fine going into it as long as there's a save for later button.
Yeah, there is.
Yeah, there is. Alright, so I got just A.
Okay. So, the next one. Number 2.
I got just
Number
A, but
I think it's C as well.
okay.
How is that quantitative, though?
Because telephone numbers are numerical.
But there's no calculating.
But it's still, yeah, I still think it's quantitative. Because the other things
If you're
have
looking
been,
for for how many like businesses start with like an 855 number, then you could count it as quantitative, because you know I can see the reasoning behind it being quantitative.
Doesn't really give us enough information to say it's not.
Yeah, that's hard because it's like, what about the telephone number? Is it a working telephone number? Is it an 855 number you're looking for? Is it the number of threes in the number you're looking for? What do you want?
Alright, well, I say we just go on. We just check and go on because we got a long night ahead of us.
Okay.
All right, moving on.
Sorry, I'm not really positive about
I
it.
also got C.
Okay.
And let's see.
We're saying C is in cat, right?
Yep.
Just making sure.
4, I got B. But I could be wrong.
I got C, and let me tell you why. Because median means middle, right?
Mm-hmm.
So if you take those numbers, 25 in order, 21, 21, 20, and 18, you're going to cross off 18 and 25. Then you're going to cross off 21 and 20, and 21 is the new median. But if you take them as they were, 25, 21, 20, 18,
Then it would change.
12. Oh, you know what? I did it wrong. Then that median is still 20. So it's going to increase. 25, 21, 20.
I took the numbers that were there, and when you do the median, you take the smallest to the largest, correct?
Yeah.
So if 12 was the smallest, and the center, you use those 5 numbers, your middle number would not be, you know, I don't think that there's enough data.
There is. So just write the numbers down in order, just the way they're written. Start with the biggest one. The biggest one is 25, and then the next one is 21, and then it's 20, and then it's 18 and then 12. So you're going to cross off the high and the low, and then do it again, cross off the high and the low, and your number in the middle is 20. But if you correct the error, so that you have 25, 21, 21, 20, and 18, and cross off highs and lows, your number in the middle is 21.
So how did you come up with the 5th number that other than 12?
Because it says it's an error and it was supposed to be 21. I'm going to run this in Excel real quick too and make sure I remember what median means for sure.
Median's the middle.
Yeah.
And you do them from smallest to largest.
So the mean is the average of all of them, whereas the median is the number that is in the middle of the data.
Right.
So even if that number was 21, the median should stay the same.
It goes
No.
up. It goes up
Go
to
up.
21.
From 12 to, that's right.
So the median will increase.
Yep.
Right.
Okay. I missed the part that it said it's actually only 21. Okay.
Okay, number 5.
95.0.
That's what I got.
What'd you say?
95.0.
95.0? Okay.
Yeah.
For a second I thought you said 99.0, and I'm like, maybe my hearing's really bad tonight, guys.
And now here's where I started feeling stupid. So.
I know. I'm going to fail our last test because I don't remember anything.
Well, our last
The
test
number,
is just over we don't have a final, it's just the Unit 4 exam.
Oh, really? Oh, that
Yeah,
just
but
made
we
me
don't-
so much happier.
But this is
There's
the
no
review
big
for
final.
that exam.
And there's everything in it.
That's very true.
So,
Oh, yeah.
I need to never trust her reviews also. Because last time, the review was not anything like I didn't feel like.
Oh yeah, nothing like the test.
Yeah, it's crazy.
Agreed.
Okay, so that's 150. The standard deviation is 10.2.
Find the 35th percentile of detailed stats. And subtract it to 1 decimal.
My husband just got accepted into the New York Law School, so he may be moving to New York.
That's exciting. Congratulations.
Or Florida, one of the two.
Oh yeah, no big deal.
So
I'd
far
choose
from
Florida.
Colorado. Yeah, I know. Okay.
I'm not sure I would ever get a swim trunk.
The 35 percentile of the LSAT. I have the hardest time doing this, so I think you have to find the Z-score, and then you have to plug it into the applet, right?
So I don't know. I did that, but then I didn't really like what I got. And so then I just put 35.3500 up in the area and used that to get a Z-score. And so I don't know. I don't remember.
Okay, so we have approximately normal. So how you do the math is 157 minus 150.7 over the 10.2. And no, because that's, oh shoot.
Nope, I did that. I'm following you.
Okay.
And that gave you a Z-score
Right.
of 0.6176.
6176.
So in lesson 5 of the text, 3.4 is calculating percentiles using normal distribution.
Rusty's like a walking textbook. He's always doing good with the textbook.
I try to look at this stuff, and sometimes I swear it changes from English to Hebrew.
Wait, why is it?
5.
You said lesson 5, Rusty?
This is normal distribution.
Well, the Ontario requires a minimum LSAT score. I'm looking at this again and I'm realizing that's kind of a random piece of information to throw in there because it's not talking about. It's not even asking you right away for the.
You just have to get the percentile.
Of the, yeah, with the mean being 150.7. So like that's the zeroed point. That's like, oh man, I should probably open up the applet, shouldn't I? Why haven't I done that?
Okay, there's the probability.
So it says, for example, the 25th percentile is the number in a data set that is greater than or equal to 25% of all the values in the data set.
Okay, using,
Or
sorry, Rusty.
we can find the values of percentiles for a normal distribution by using the applet to calculate the Z-score corresponding to a specified area, and then plugging that Z-score into our Z-score equation. And it shows, first we need to find the Z-score that corresponds to the 90th percentile, and they just plug in 90% or 0.9000 into the top, and it ends up with 1.282.
Okay, so I did that with the applet. I shaded to the left, and I put 0.3500 up in the area on the top.
Mm-hmm.
And that gave a z-score of negative 2.357.
Negative 2.3.
So you shaded which side?
I shaded to the left because it was the 35th percentile.
Okay, so that's 0.23 or whatever number you said, and that's the representation. That's how many standard deviations away that is, right?
I don't know.
Because that's what the z-score represents. It's how many standard deviations away from the mean you are.
Which,
If you know the standard deviation is 10.2, then having the z-score, you can multiply it to give you the number. Because if it's 2.4, man, I forgot the number and I forgot to write it down.
for what? On the applet?
Yeah. The z-score, what's it give you? Negative
2.357.
So 2.357.
Say that again, Penny.
Negative 2.357.
So that is the z-score.
And so it should be 126.66 is the 35th percentile.
And how did you get that?
Okay, so you know it gave us the z-score, which is negative 2.357, right? So that means it's 2.357 standard deviations away from the mean. And if we have the standard deviation of 10.2, you multiply 10.2 times 2.357, because that's how many of them is away, to give you like 24 point so-and-so.
Okay.
And then you take that from 150.7.
I'm gonna screen share for a second though, because I think I was wrong. Let me show you. Okay, can you see this right here? This is calculating percentiles from a normal distribution. Let me make this my whole screen, sorry. Oh, don't do that. Okay, so it says though that you need to shade like this. Can you see that?
Yeah, if it's like the 90th percentile, but that's not the 90th percentile. We're doing the
35th.
35th.
So
that's only
I only
from.
did the left side, is that right?
Yeah, fine. Because if you did the other one, it would be like up to the. Because watch, if you click it, the area from above should change too. I think. Yeah, see?
Yeah. And if I go to the 35th percentile-ish, oh,
So yeah, type in at the very top there, Tammy, just type in 0.35.
okay, oh, there it is, negative 0.385. Make it big here for everyone.
Okay.
So yeah, so it should be 146.7 now.
Then we're going to times it like this, right? 150 times 0.385. And you got 150?
Wait. 150.7 times 0.385?
I'm asking. I'm not telling. I'm asking. Let me go back to the book.
That figure is.
It doesn't make sense to me.
Did that come from your text, from that
No, that what I was showing you was my start on this homework assignment.
Okay, so a standard deviation is only it's 10.2 away, right?
Right?
And so if it's moving 0.385 of one standard deviation, it should be a fraction of 10.2 away. And so that's why I got 146.77. Does that make sense?
Mm-hmm. I'm just reading this section of the book again here real quick.
Yeah, I'm reading it too.
So they solve for x. Oh, there we go. We've got to put it in that equation that you had earlier. Z equals x minus mu over the standard deviation and solve for x. Okay, and then we've got to solve for x.
Okay.
So that's what we do with that number.
Jesus.
Wait.
Okay, wait, Tammy, can you bring that up again? What does it want you to find out for there?
So once you have your z-score, then you solve for x in the equation, in this equation here, right there. And it says, here's the math on it, blah, 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 blah. And then it says the 90th percentile of the batting average is, and it's the same thing as when they solve for the x.
Tanny, can you up to that equation one more time just so I can make sure I have it written down right?
And so x is our unknown, and mu is that statistic or the number they gave us, which was
150.7.
I thought the mu was the mean.
U is the mean.
Yeah.
X is 57.
So
okay.
So it's 150.7.
So it's, yeah, so that equation says it's 157 minus 150.7 divided by 10.2.
I don't think so.
That's what the equation is, though. And that's why I'm confused, because it gave me 0.617 thick.
Because we're not solving for x too. We're not.
No,
We don't-
because we don't need that.
They give us our x. They give us enough information.
Oh my goodness.
See, I did it. Here's my homework, and I did it the other way, where I put the 2 and subtracted and divided and got 0.617.
Mm-hmm.
And you multiplied that 0.61764
Okay.
to what value?
Yeah, I don't know, Rusty. I didn't know what to do with that. Did I? So, I mean, that's the equation we just looked at.
Okay, that's what I got for Z.
Okay, I'm gonna go looking back through old homework and see if I can find the percentile.
Oh, to be honest, I think we should kind of just ignore the 157 because that doesn't seem to fit. Because we're trying to find the 35th percentile of the 150.7 because that's our mean. We know it's the mean, and that's what the whole statistic is based off of, right?
I
Not
agree.
necessarily
I think they just put that in to confuse us.
I think that's really what it's for. I think she was trying to trip us up with the question that we are trying to do the 157 minus the 150.7, but that is actually doesn't make sense because it's like that's their minimum requirement. That's okay, sure, but it doesn't mean everyone's going to get that, and we should base our mean off.
And really, we're asking what is 35th percentile is what number is. So we don't know our X. What is that? That's, you know what I'm saying?
Right. The 35th percentile was that z-score that you got, Danny, which was the .385, right?
Yes.
Negative.
Yeah.
Which is negative .385. So that's it's 38% of one standard deviation away from the mean, which is 150.7, right?
Yep. So I'm going to invert and multiply and see what happens.
I just got into the homework assignments for that lesson 5, the preparation assignment.
Mm-hmm.
And there's a question in there, what proportion of the people who take the quantitative portion score above 165, and then it gives a solution, and it's z equals x minus mu divided by standard deviation, and it comes up with a z-score. So you plug in the z-score, and you shade the applet, and then it says if a student scores in the 10th percentile, what would their corresponding z-score be? So, and what they did was they just plugged in 0.1000 at the top of the applet.
Okay. So I've got an answer for us.
Mm-hmm.
My answer is, hold on, if I can type right, 50.7. No, that's not right. Hold on. 150. Am I still screen sharing?
Yes. Kind of funny.
Yep.
Okay. So I took the 10.2 over to the other side. I times it by that negative 0.385. Got negative 3.927. And so now I am getting x by itself and subtracting that. So I say x equals 146.773.
Yeah, that's what I got earlier.
Okay.
0.773.
Yep.
Yay. That took way too long.
I know, right?
That was
That's what I was
20
worried
minutes.
about.
So number 6 is 146.773.
Yeah.
Yep.
Okay.
Number 7. We got C. I don't know.
We're on report, aren't we, Danny?
Yes.
That would be a bad thing.
Pardon?
That would be a bad thing if we weren't, Rusty.
Oh. We'd have to start all over.
No, we would not.
It's already 10:21 from.
Anybody watching the video would think, my gosh, those guys really are math wizards. Look how fast they go through those answers.
Hey, Callie. Real fast.
All right,
What do you
so
need?
what did you guys
Conference
get
call
for 7?
for school.
I got C.
Good. Will you send me a text with, I need the year of the car, the make of the car, and the VIN number. Okay, love ya. Bye. Oh, darn.
Rusty, that's a bad question to ask.
Hello, are you guys there?
20 minutes before the meeting started.
You guys would be proud of my technology there. Okay.
Go, Tanny.
Suppose the sample size for this study was 2?
But you know what? Okay, but it doesn't matter because it is going to be the same as the parent. It's still going to be skewed right.
Oh.
We're on number 7, right?
Yeah.
Yeah. How would that? Wouldn't
Oh,
even make
wait.
sense.
No, they take a sample of 70.
Well, yeah, that was of the top part. Like I said, they've done that. What they're talking about a subset. So this is like your sample of a population. So not your first generation, and not the kids, but the grandkids. If that makes sense.
It does.
Mm-hmm.
But I mean, it's only 2 of them. I'm with Tim, right? That makes sense. I mean, they say my parents are crazy. Crazy. I think it works.
All right, number 8. So this one is that same formula we did before, but then
This one actually gives us a sample size.
Yeah.
and then you take it and do it. My O is the standard deviation, but divided by the square root of n. You can. I don't really take the time to make it math right, but does that make sense?
Yeah.
So what did you come up with? 0.003 is what I got. 2.236.
For a z-score, is that what you came up
That's
with?
what they're asking. Yeah.
2.236.
That's what they're asking for.
Okay.
Now the next one.
Number 9.
Ugh, I hate these.
So you just get the z-score and then use it to go into the applet.
Okay.
Right.
And I came up with 0.000.
Oh, then I probably shaded the wrong way.
Greater. Yeah, it's only on the right side of it.
Okay.
0.0127.
Oh wait, no, hold on. What is the probability for these tanks? Of
The tanks will be greater.
oh wait, what if you do? Oh, nuggets. Because this includes the mean, so it should be the middle section should be highlighted too, because the z-score should be reported to the left of it, and then the middle should be shaded and the right should be shaded. Does that make sense?
Yep.
Which I'm reading this wrong. And that gives the. Does anybody get it yet?
Let me see. Negative
9.
2.3.
Oh.
Yeah, I got 0.998. Or 0.9908. So it's going to be 0.991.
Yeah, 0.99. 0.991.
Okay, 0.991 it is.
I got A for 10.
Okay.
So for that one, it was 0.99.
991. You got A?
Yeah, but I don't know if I'm right.
I was oscillating there between that one and D, and I chose D in the end.
That's what I came up with. There's something that I'm remembering, and actually in 9, I believe it's lesson 9. There's the p-value is the probability of getting a test statistic at least as extreme as the one you got, assuming HO is true.
So a hypothesis test, though, is what this is asking about. So maybe it is one.
I just.
And the level of significance is the standard for determining whether or not the null hypothesis should be rejected.
So that would be answer C.
Yeah, so we've got 3 different answers. Of course.
I have no input because I always get all of these wrong. I can never keep them in order.
Rusty, what lesson are you in?
Down at the very bottom summary.
Okay.
The level of significance is the standard for determining whether or not the null hypothesis should be rejected. What is the question?
Which of the following best describes the notion of the the significance level of hypothesis test?
Okay, so the answer is the level of significance is the standard for determining whether or not the null hypothesis should be rejected. So that's going to be, what is that one? C.
Okay.
Now we know.
Yeah.
Is that what you think, Rusty?
And where did you get that one?
I read that final, am I still screen sharing?
Yeah.
Okay, let me pull it up. I'll show you what I found it right here. Right there, the third bullet point.
Okay.
All right.
Moving on. Number 11.
Moving on up. Moving on up.
We're only a quarter of the way done.
Hey.
Don't say that, Rusty.
Positive.
Cry.
I got B.
Okay, number 11. I chose C.
Maybe it's B and C.
Somewhere in her.
Will contain the true mean. Maybe you're right. Confidence the true mean if the height is somewhere in our confidence interval. I don't know. Well, approximately threw me off.
You know what? Or somewhere in our confidence interval. I like B too.
Maybe we
I
can
don't like A.
click both.
I don't like A. What?
I said maybe we could click both of them because it does say maybe more than one correct.
Then if we're wrong, I don't want to be wrong.
Yeah.
Haven't we been not to use the chance
Yeah.
when there's no chance?
Mm-hmm.
And so you picked E,
I
Macy?
did. Does it say chance in there?
No.
Oh, okay.
No, the one above it says chance.
So we know it's not that one. So B and C.
And I know it's not D. In the U.S. or confidence interval.
Just did.
It could be E too, because 95% of heights of female adults in our sample are in our confidence interval. Ugh. Why does this class have to be so hard? I'm so over this class.
My husband has to take math 1841 for his major. And I'm like, why didn't we do this together?
Yeah. My husband took it 2 semesters ago. But he doesn't remember.
You mean it didn't improve his everyday life?
No,
Okay.
it really didn't. Okay. Guys, this is bad. I don't know.
Okay, I'm gonna go with B and C, and I'm moving on.
Okay, let's go.
Okay.
For 12, I got C. But I didn't know on this one. Because there's only 16 blue wells, and isn't there supposed to be 30?
No,
Yeah.
the answer for sure on this one is A,
Okay.
because it says that it comes from, their data follows a normal distribution.
Perfect. Moving on.
And when the parent is normal, so are the kids.
Okay.
All right.
A.
I know
A.
some parents that are normal and their children are
Casey, don't talk about me like that. That's very rude.
I don't know your parents.
Oh, right.
Okay. And to be honest, this is as far as I got.
Yeah.
I don't have any more answers.
I quit it. Like,
That's the scary part.
I kind of just went through and picked some out. So that's why this is going to take us so long.
So if we to do only part of this tonight and finish it by Thursday, do we still have to get online?
Well, here's what I propose. And we can choose to do what we want. We can try to get to, there's 43 questions. So we can try to get like to number 20 and then schedule a time Thursday, and we're going to have all of our work done, and we're going to get online and just blow through the answers. And we can record that and just make sure that everyone has the same answers. We turn it in and call it good. Or we can struggle through it question by question, but I kind of think if we committed to each getting it all the way done, then we could do it fast.
If we can do it fast and just save it for later, we can have it all done and count it as a Thursday. Is that what you're saying?
That's what I'm saying.
And then we can go ahead and go through it ourselves and try to figure out where our problems were.
Yeah, what do you guys think of that?
Agreed. Okay. So I say this is just my input on that. I say we go till 11 or whatever time it is. We have 30 minutes, and we get as many as we can done, and then the last ones we just do what you guys said for Thursday.
Okay, so let's skip any that need calculations.
Okay.
Well, that's a good idea.
You're saying 11 o'clock, and you're using Hawaii time?
Basically,
No.
so we've got a few hours, Rusty.
Okay,
Why don't we use Nelson's time?
so
I'll drink an energy
15
drink.
and go to 16.
Based on the results of the test. Oh, we would need to know the
Let's just,
p-value.
I say we just go through it. I say we open up the data files and just do what we can, because these all are now like calculated.
Okay, from here on out, it's all calculated.
Yeah. Basically, there's only a few, because I went through them and tried. You know what? The very end ones, like 39 through 43, let's go down to them, because those are all like the one sample, like you have to see what they are.
Okay.
It's gross. Why would you suggest this, Mason?
I know, I hate these ones. That's why I suggest it, because I don't want to do them by myself.
All right. So everybody at 39?
Yep.
Yeah.
Okay. So, in the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of new parental care program in reducing the number of low birth weight babies born. The study, 30 mothers of all who live in poverty participate in the program. Birth weight data is recorded. Which hypothesis test would be appropriate for the study? See, this is trippy because there used to be a question about this. They compared those that lived in poverty to those that don't. but now we just have this single
And
property.
we have the mean.
Yes. So this would be
Paired.
A.
A one
yeah, it would just
sample?
be A.
Okay.
Yeah, because it's not comparing anymore because there used to be comparing,
Oh,
but now it's just the one
they're
test.
trying to
of
throw us
the-
off.
Exactly. Because we've had a question very similar to this.
She does that all the time.
So this is A.
Yeah, for 39 is A. Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. Standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03. Which hypothesis test would be most appropriate for this test? It's going to be a one sample, in my opinion, and it's going to be the one that has the standard deviation, but I can't remember which one that is.
T-test does not have a mean, correct? Or
A
am
what?
I doing that wrong?
You're probably right, so would it be the Z? Because it does have a standard deviation.
Trying to remember which.
I'll go look at my notes.
Man, I have no idea anymore. So obviously we know it's a one sample, but a Z or a T-test. This is where I
Isn't the t-test when you don't know the standard deviation?
That's what we're looking up right now.
There's my flow chart.
You remember it, Tammy.
Nope. Nope, I'm not hopping out there with great confidence.
Ah,
One mean okay. Yep. It is a Z.
So it's a Z-test.
So does that mean our first answer's wrong?
I think A doesn't give the standard deviation. I think the first one is B.
Is it t-test? I agree too.
I'll jump
So
on
we
that
have-
bandwagon.
B for 39 and A for 40.
Yeah. Clint, you can't be a bandwagon jumper.
I am. Okay, tell you what, I'll drive the bandwagon, but it doesn't mean I started it.
That's what everyone did when the Broncos were winning. They all
Hey.
did it on the
That
train.
is so true. I've been a Broncos fan since I was like 13 years old, though.
Me
So
too.
You
been
should
around.
see. You
I've been
should see
around
the
since before.
ridiculousness of. I'm sorry.
what was that?
Nobody. I mean, very few people cared about the Seahawks around here. And now every doggone business has got it painted all over and flags. And
My husband
I just
actually sells Bronco jerseys for like $50. And so
To be honest,
when they weren't doing very well, we weren't selling any jerseys. And then as soon as they started doing good, everyone wanted jerseys.
okay.
And everyone cussed Peyton Manning till they won the Super Bowl. Anyways, back on to the topic.
Okay. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation?
It's going to be proportions, right? Am I wrong? And I think it's one.
Just of one
No, it should be-
proportion for
I think so.
I believe so.
How come I can do so good on these? And then on the front test?
Yeah. I don't know. I didn't do too bad on the last test. Like I could have done better, but I didn't do awful.
I did awful. Anyways. 42.
Having all kinds of technological
Let's
issues
stop
that night.
it. A marriage counselor conducted a study of couples, categorizing each of the couples as communicative and non-communicative. Among these things, the counselor wanted to see whether the percentage of communicative couples whose marriages ended in separation or divorce, the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which hypotheses test would be most appropriate for this study? 2 proportions.
Yes, with 2 proportions.
Yes. I don't mean.
I think.
I think so, because it's not numbers. It's back to thoughts and
It's how many percent of each group was divorced in the communicative or non-communicative.
And they're comparing them. So.
And they're comparing.
and it's categorical. That's what I
Yeah.
wanted to say. It's a categorical kind of thing.
Yep.
Okay. 43. A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in radio advertising. Which procedure? Well, obviously, since it's linear and it tells us that, we're going to go with I.
I think so too.
Go with that one also.
See, look, guys.
Okay.
Just you guys were talking about football. My wife's cousin is the coach, the head coach for the Oregon State women's basketball coach for a team,
Oh, no way.
and they made it to the Final Four, first time ever.
Wow. Done.
Okay, let's go to question 19. Because I think we can answer that one.
Okay, so we know it's not A because it has the word chance.
Yep.
Mm-hmm. And I think it's B.
I think it's
Because it says the true mean.
So it's B? Is that what you said?
and I'm between B as in boy and D as in dog.
Okay, so at one point in my tutoring, she said
Oh.
it's either going to be the true mean or it lies between 2 points.
Okay, so let's go with B.
But then look at the last one.
The last one is sample means, and it's
Oh, yeah. It's wrong.
Yeah.
That's B.
Okay, so now let's do 20.
P
B
equals
is over 5 with the smallest value of n that satisfies the requirement. Normally distributed. It's, well, if P is 4 over 5, which is
Yeah.
just, in essence, the decimal point, you have to do n times P, and then, what is it, 1 minus n times P?
NP is greater than or equal to 10, and N times P minus 1, right? Or 1 minus P
Yeah.
is greater than or equal to 10. So 4 divided by 5, trusty calculator.
0.8.
Okay.
So n times P, you get it to equal 10.
So 10
Over 10.
divided by 0.8, right, is going to be 12.5.
Where did you guys get
Is
10
that the
from?
one?
For,
Because that's the number it
greater than or equal to
Oh, yeah. Okay.
so one is 12.5, and then the other is
50.
You got 50?
Yeah, because it's 1 minus 0.8 is 0.2, and n times 0.2 to get 10 is 10 divided by 0.2.
Yeah. Nope, you're good.
Right? The minimum it could be is the 51 because it's larger than the other one, right?
Yep. Okay.
I hope that's right anyway.
So you have n times 0.2, right? Is greater than or equal to 10.
Right, which is 50 times 0.2 with 10. That's an easy way to think about it.
Okay. Yep, I agree.
Okay. So,
All right.
try 21.
Sure.
Oh wait, this requires. Oh no, wait, no, it doesn't.
Yeah.
Meh.
So it's the same greater than equal to's.
So is n your 0.233?
No, n is your sample size.
So that would be like the 40.
Oh, yeah, okay. So 40.
And then you actually use the 0.233. You don't use the 0.250.
So it's going to be 40 times 0.23.
Yeah. Which it's not.
So is it the last one?
See, and this is where it's tricky. This is where it's kind of tricky, is because he says you don't determine the probability of the next season being over 0.25. But the only problem with that is that hasn't occurred yet, and it wants you to. That's where it tricks you. I remember this from the test or something like that. It wants you to think to use the 0.25 as the p, when actually you're supposed to use the 0.233 as the p. So it should be D. It's 40 times 0.233 is less than 10. So the conditions aren't.
I agree. Okay.
So it's D.
Yes.
Correct?
Correct. Should we keep going? Because this isn't opening a data file.
The next one wants us to open a data
No,
file.
it doesn't.
Oh, okay, sure. Let's just take a simple example.
I don't know.
I'm getting tired because I've read the thing 3 times over and I'm still not sure what it's asking.
Okay, so I know what it's asking. So a geneticist does her own study to figure out how many gametes make male puppies, and she gets, in her studies, she gets 51.2%.
Right,
And so we
it'd
have
be-
to interpret it.
It would be, right? The 51.2% of the gametes in the sample have the male chromosome.
Yes, that's what I think. Because it's not of all dogs.
No.
Or females.
Yeah, because we aren't dealing with females. It's the gametes, so it's D. Haha, that's a joke.
Thanks for pointing that out there.
It is definitely getting late.
If we can all laugh at that joke.
Okay, the next one's a simple probability. Okay, so I think it figures out that they have told us that 45%, and so 45% is 45 over 100. And in this, we want to know if it's fewer than 120, 320 over 750. So we're gonna get that to be a percentage, right?
Did you do 320 divided by 750?
That's what I'm thinking I'm gonna do.
Okay, it's 0.4266.
Where did you come up with the 4266?
Divided 320 divided by 750.
Why are we doing 320 divided by 750 again?
Calculate the probability that fewer than 320 adults out of the 750 adults in this study have those conditions. So I think we're just doing a probability.
Okay, and so you start with 320 divided by 750?
That's what I'm thinking. 0.427 is what the math is on that.
Yeah.
But then we can, I'll check these as we do our own work too and see if we come up with different answers.
Well,
P-value.
Oh, this one's easy. It's 24 is B.
It tells you that in the question, huh?
Yeah, right?
I don't know.
you calculate this.
Okay, is oh, you know what? It's not that. Because it is equal to and not equal to. So it's going to be both sides of the test statistic. Or on the applet.
I didn't think it could be that easy, but
The area to the right of 1.344?
I think it's going to be to the right and to the left.
So it's 0.182.
Because it says it's not equal to it.
0.2.
So did you get 0.182 from the applet?
182. Yep.
All right. 26. Boy, we're doing good. Or 25, we're doing good.
It was 0.182?
Yeah.
That's all?
I didn't.
For which one?
That means it's only, for 23, that means it's only 18% probable? Because the study shows 45% of all adults over 65 suffer from those conditions. And so the probability that 320 of them out of 750, well, 45% of 750 is about 340. So it should be, I figured it would be higher. Am I just talking crazy? Maybe I'm just too tired.
No,
Well,
I see what you're saying, but when we put it into the probability applet, that's what it says.
No,
Unless we're not
but
doing
we
something
didn't,
right.
we didn't do, that one didn't have a probability applet. That one was just straight division.
The one before.
Okay, so 750 times, because you're back on 23, right, Clint?
Yeah.
750 times 5 is 33.7 or 337.5.
Right.
And
So
if
that's-
we do
Theoretical number that should have.
significance.
So I'm just
And
surprised.
really, yeah, calculate the probability that fewer. Okay, so that answer might not be right.
Oh no, that fewer than. Okay, then yeah, no, that makes sense. I'm sorry. I was just thinking about how many would get that, not fewer than. That makes sense because you have a low probability that fewer than that number is going to be. No, you guys are right. 0.182 is something that's right. I was looking at the question wrong. I apologize.
182, that next question has nothing to do with the question above it.
No.
No.
Okay. So we're on 24 now, and it was C, right?
Mm-hmm.
Okay. So now we're back to breeding dogs with 5 minutes to go.
A.
Rusty, you got A?
Yep.
Okay.
Yeah, I agree.
The study is planned to compare the proportion to
I'll agree.
sequentials.
Because it's not a proportion, so the greater than and less than n's don't count.
Okay, so 26.
Yep.
Oh man, I'm getting tired.
Okay, so this one we have to do. This one we have to do the NP thing.
What was that?
Does that mean your dog
Don't
tired?
you know?
Oh wait.
You didn't eat some already? Hmm. It's 11 o'clock.
So 41 men times 0.67. And
56 times 0.84.
Is
No.
the third one B?
I think it's D, the no, because n times 1p, 1 minus p is less. Because if you do the women's one, because 1 minus 0.84 is 0.26 or 16.
1 point. It's 0.16.
So 0.16 times 50, which isn't enough.
so it's the women's part that you have it doesn't match up.
Yeah.
I agree. I was a little slow on the math, but I'm there.
Okay. And then 27 is they're just trying to see if there's a difference in weight. So it would be B, the mu difference does not equal 0?
Mm.
Or is it the mean of 1 does not equal the mean of 2? Wanted to test there's a difference between.
I think it's B for the difference.
I think so too.
Because the mu of 1 would be group 1 versus group 2. And that's not true. They're just
Right.
looking at the same person.
Oh, right, of course.
Okay,
Right.
last one, 28.
Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. The exercise group used linear regression percent compliance. I'm lost.
Okay. I know what
Oh,
this
no, I'm
is.
not.
Are you still lost?
No.
No, you're not lost anymore?
No, it says his actual weight loss was 5.5 pounds higher
Then
than his
his.
predicted.
Yep. Yes.
Okay.
One of. Oh, but if or is it C as in cat? No, hold on.
If they didn't exercise?
Because it's a linear regression, so it's going to take, you know, the one over the other and make a line predicting. Nope, I'm going with B. I'm going with B.
Mm.
Yeah, because they're both testing what weight loss, what weight is lost, not necessarily the difference in exercise or don't exercise. They're just saying that one group included exercise, where one was just diet.
Right. And then that made a line, but his residual, which is the difference between what he did and where he would have been on the line.
Right.
Yeah.
So he was actually 5 pounds higher than his predicted weight loss.
Yep. All right, so I'm going to post this one, and when are we meeting on Thursday?
I can only.
I am home by 6. I better say 6:30
because I work
Pacific time, which is 7:30 Mountain.
Clint, when can you meet?
I don't get off work till 8.
Okay. So 8 is 7.
I'm here in Idaho.
So do we want to say 8 o'clock Mountain time again? Or do you need it to be 9?
8:30 to give Clint a little bit of
Yeah.
push time to get home.
Okay. Yeah, that'd be fine.
8:30 Thursday night. Come with your answers and let's cruise through it.
Alrighty.
Sounds great. Good work. And
March 31st at 8:30.
And if you get a chance, look through. I sent them in the email to Macy. Some of the statistical tests that I've run. See if you think I'm on track with those, and we'll go from there.
Okay.
All right.
All right. Have a good night.
Good night.
Night.
Bye.